So here, as per the schedule given to me, the time slot for ED subject is today's date, 10th October 2020, and I just already shared the time for this class 3 p.m. to 5 p.m. One 2 hour, but not sufficient. Only 1 hour or 1.5 hour sufficient for this session. Today I covered the half part, and then remaining part I will cover in a Monday's lecture. So now already you are familiar, right? So I am Anil Bhagat, working as assistant professor in ENTC department, and I taught this subject in 4 times in previous. So very important is to be the weightage for this subject is 12 marks, and I will attend, or I will get this 12 mark out of this 12 mark in incoming exam, right? So you just try to understand that type of way. So this is the basic, the weightage marks for each and every subject, right? So starts from engineering mathematics. You already know that, you already attended the class of engineering mathematics. Maybe signal system. I already saw this message of signal system. And now here we right now in electronic device. So weightage marks for 2020, right? So in exam, like last exam is 12 mark, so weightage marks for 2019 14 marks, and now 2018 14 marks, right? So near about, right, 13 to 14 marks of this subject. So then this AD subject is very important. Suppose if you crack the gate at that time, you at least you attend the, or you should get the 8 marks out of that 12 marks, because the some problem in electromagnetic concept, right? So vectors and all this concept, included in electromagnetics communication. So simple, but now then there are a number of concept, frequency related concept involved in that. Control system, okay, the problem of control system, that the control diagram and all this thing, right? So Bode plot, then the root locus, the different types of the concept involved in a control system, right? PID controller, PI controller. Digital circuit, okay, is easier than the electronic device. But now, okay, after attending this lecture, you should know, you also familiar with this subject. So electronics devices, wattage for this income exam is 12 to 13 marks, near about. So all of you clear? So this is for the wattage mark system. Second, the weightage as per the paper format, right? So you know that there are three sets of the GATE exam, and in that, so distribution of electronic device into three sets. Set 1 marks 13, set 2 marks 9, and set 3 marks 9. So average marks of this electronic devices is near about 10.3, or 10 to 11 marks, near about 10 to 11 marks present in each one. So total marks for this is not for only for 13 marks, is addition with 9 plus a 9, right? So all of you clear? This is the basic the weightage as per the paper format. And now then the previous slide shown the actual weightage for the ED subject in GATE examination. So is that clear? Okay. So now then the priority for subject study. So how will prepare the GATE exam? So now then the priority also given in a one of the very popular GATE classes. So first priority is always given to EDC. Second, network and signal system. Then third, electromagnetic. Fourth, control system. Fifth, digital circuit. And sixth, communication. And last one is the analog circuit. So the first priority always given to the electronics device, because you will get suppose if you study the all the topics in a details, so now then you definitely get the you will get the 8 marks out of 12 marks, right? 8 marks out of 12 marks, and now easily crack your GATE exam. Only 26 is required, marks required for the crack the GATE exam, right? 26 or maybe 27 marks for the GATE exam for open, and 17 marks for the category, okay, student. So this is the priority. And now then first of all you tried, you just try to study in the electronics device. So now then here the syllabus for this ADC, okay, divided into three, the total five uh, sub point. The first one is energy band in a intrinsic and extrinsic silicon, carrier transform, diffusion current, drip current, mobility, resistivity. So this part you have studied in a first year physics subject, right? First year physics subject, intrinsic, extrinsic, silicon, Fermi level, right? So all these levels also we will recall in a 12th session. So how will distinguish the or compare the intrinsic semiconductor and extrinsic semiconductor? So based on their equation and the material used in that, right? So is the impurity added in a pure semiconductor or is just pure semiconductor used in the actual construction of the devices? Carrier transform, diffusion current. So now then the Poisson and continuity equation is also important. So now then, okay, one question was present on that Poisson and continuity equation in the last GATE exam. I already okay, gave the exam of this GATE exam to 2019, right? 20. PN junction, general diode, BJT, MOSFET, capacitor, MOSFET, right? MOS capacitor and MOSFET, LED. All these points you have studied in a secondary syllabus. So BJT nowadays the second year student studying the MOSFET only. Now in my time I was studied the BJT only. Only small part of the MOSFET included in my syllabus in 2008 or 2000, sorry, 5 to 6 year. But now here you also you okay, your batch is also study the BZT some in a combination half portion of BZT and half portion of MOSFET. But now here PN junction is very important, included in first year syllabus. The PN junction diode used in a rectifier circuit, then Zener diode, BZT, MOSFET, capacitor, and MOSFET. The photodiode and solar cell is also important point for the GATE exam point of view. IC's fabrication process, oxidation, diffusion, ion implementation, photolithography, and twin tube CMOS process. All these points we will discuss one by one. Okay, let's start the actual syllabus. So energy bands in intrinsic and extrinsic semiconductor. You know that first of all, the silicon is a very popular semiconductor device used in each and every devices, right? The construction, right? Fabricate using the silicon material, right? Silicon material or germanium material. So silicon having the trivalent or pentavalent impurity atom in its crystal is known as the extrinsic silicon, right? Extrinsic silicon. What is the definition? Silicon, okay, silicon in a combination with trivalent or pentavalent impurity is very important. Trivalent impurity and pentavalent impurity added with the pure semiconductor silicon, we call it the extrinsic semiconductor. Okay, extrinsic silicon. Intrinsic silicon is nothing but the pure, right? So pure is a single, the Si sharing the one Si with another neighbor Si and form the crystal, and that crystal is nothing but the intrinsic type silicon crystal, right? So now then there is no any doping process used in a intrinsic silicon. So then the doping process is very important. So doping is nothing but the formation of N type and P type semiconductor with the help of the doping process. So doping is nothing but the impurity added with the pure semiconductor. Impurity added with the pure semiconductor is nothing but the doping, right? So impurity atom, impurity material is always called as the extrinsic silicon material, and the intrinsic semiconductor is always called as the pure type, or there is no any impurity in that. The doping process not used in a actual. The basic diagram for this the material is nothing but there are two bond. Suppose if you form the crystal, at that time by default the two bands present in a device, in a material. So one is nothing but the EV and second nothing but the EC. There are two boundaries and this boundary is separated by the EZ. What is EZ stands for forbidden energy gap. The gap present between these two bands is nothing but the energy gap. And now then this level electron volt, right? The unit of energy gap is nothing but the EV. And this EG in terms of the Fermi level we will represent, right? In terms of the Fermi level. So conduction band EC and valence band. There are two bands present in a crystal. So suppose in a equilibrium condition, in initial condition, that means you not apply any type of voltage to device. Device is single piece of the semiconductor material. Piece of a semiconductor material. There is no any connection. There is no any apply voltage across it. So this is about the intrinsic and extrinsic semiconductor definition. Trivalent and pentavalent impurity added with a pure semiconductor we call as a extrinsic semiconductor, and intrinsic semiconductor impure, right? So pure semiconductor. So this is the principle of conduction of the current into that material. The conduction band yellow portion, and then here the blue portion valence band. The energy in between these two band, and this energy separated by the, you know that the structure of the atom, right? Silicon atom. So there are total 4 to 5 the cell, right? The valence cell, and this valence cell moving around the nucleus and number of electron cell moving around the nucleus. So then the protons, number of protons is equal to number of neutrons, right? You know that the positive charge, right? And the electrons are the negative charge moving around the nucleus. So now then this part you already know, so that's why I have not added here. But you try to understand the principle of this conduction, how this current start flowing. So now then the valence band, you know that in valence band there are electrons, right? There are number of electrons present in valence band. And now then what will do in this material? You apply the external energy, and now these electrons present in the valence band moving into the conduction band. Now let this or the break their bond, and now then the electrons present in the valence band moving into the conduction band. Now let this sorry, here power is off right now. Okay, the power cut, and I'm not able to take the lecture using mobile phone. Okay, so now then we will meet very soon. So I will share the same link. Suppose power is coming. Okay, just your attendance, okay, also mark. You just put your roll number on chat box and you can leave now. I will share the link once again. Suppose power is coming, right? So thank you for coming, thank you coming for here, and I am also waiting for you, right? Once again, and just you motivate the other student also. बाकीच्यांना पण बोलवा बरं का, बाकीच्यांना पण बोलवा. So I will cover the very important topics that is very useful for you. Thank you.